6B-4 exponential growth and decay applications. So applications means that we're doing real world problems. Okay, so general formula, you guys know this right here. Okay, drop my marker. This right here is my equation for exponential functions, right? We've talked about this all last week. Okay, so that's my equation for exponential functions. Like linear, what's linear's equation? Y equals mx plus b for linear. This is exponential, which is y equals a times b to the x power. Now, everything on this equation has a meaning for word problems. Okay, so we're going to start with y. Well, what does y usually mean? Your what? Your total. Okay, so it's your total. So what we call it, it's the same thing as total, but we're going to say it's the end value. It's how much you end up with. So just like total means, okay, it's how much you end up with. Your A, okay, the A, whatever number you're going to put in the A spot, that's always your initial value, which is the same thing as your y-intercept, right? Your y-intercept is where you start. Your A is your initial value for word problems. Okay, your B. B is going to be your growth / decay factor. And then I want you to put a percent sign somewhere right here. Put your percent sign. Okay, so these word problems today are going to give you a percent. That percent is always going to be where that B goes. Okay, your X. Your X number is going to be standing for time. Time. So all these boxes should be filled out. You need something to write with? What happened to the pencil, Levi? I let you borrow. Can you use it again? Alright, now this part right here is important, super important. So put a star by it. Okay, whatever you need to do to make it stand out. It says, if we have a growth problem, okay, if we have a growth problem, we plus 1. And if it's growing, it's a plus 1. What do you think decay is going to be? Minus 1 to the what? B. So whatever that B is, which is going to be your percent number, right? Everybody see how that's your percent number? Whatever that B is going to be your percent number. You're going to either plus 1 or minus 1. Okay, we need to review real quick on the back. If I have 20%, how do I write that as a decimal? How do you do that? Well, right now, here's your decimal. How do I move it? 1, 2 jumps to the left, so 0.20. That's a decimal. If I have 3.5%, how do I write that as a decimal? Well, I move that decimal how many times? 1, 2 to the left. So now it's 0.035. What if I have something like 6%? How do I turn that to a decimal?
Move it twice.
Huh?
Move it to the left.
Move it to the left how many times? 1, 2, so 0.06. Okay. Why do we have to change a percent to a decimal? Can you put a percent sign in an equation? No. You cannot put a percent sign into an equation. Can I put a decimal into an equation? Yes. Okay, so any percents today, we got to change to decimals for our equations. All right, number 1. The population of Johnson City in 1990 was 25,000 people. It has grown at a rate of 3.2% per year since 1990. Graph the value of population as a function of time and years, then identify key features of the exponential function. Okay. Is this a growth or decay problem?
Growth.
How do you know that it's growth? because it says it has grown, right? Does everybody see grown? Okay, so what I want you to do is I want you to circle grow. Now, because it's growth, are we going to +1 or -1? +1. Now, the growth and decay, look right here. What number is the growth and decay factor? Whatever that percent is. Okay, so look at this number 1. What's my percent? Okay, can I put 3.2 as a percent in my equation? So what do I need to do? Move your decimal 1, 2 times. So this is really what? 0.032. Now, you need to write that above 3.2%. Do you write it, Leba? Now, we said we're going to do what? +1. So I need to do 1 plus my percent number, 0.032. So I'm going to do that in the calculator. So I'm going to do 1 plus, because it's growth, I'm doing 1 plus 0.032, my percent number, and I get 1.032. So my growth or decay number is going to be 1.032. And what letter is this going to stand for? Your B. This is really your B. Okay, that growth or decay number. Okay, so here we go. We're going to write our equation. Do I know my total amount at the end? No. Okay, we don't know the total amount of population at the end. So y equals, that's my end value. Now, A comes first. Huh? I took it back to the library. Thank you. Okay, A comes first. What does A stand for? Initial value. So what's my initial value? Well, what are we talking about? What are we talking about here? The population of Johnson City, right? Well, what's the initial population? 25,000. Don't put a comma in it, okay? Don't put commas in equations. Okay, so that's my initial value. What is my B? Well, we figured that out right here, right? You guys told me this is my B number. So I'm going to put that for B, 1.032. Do I know the period of time that we're looking at right now? Does it tell me exactly how many years we want to know? No. It does not say after 5 years what was the population. Okay, so right now, I don't know the time frame that we're looking at, so I'm just going to leave it X. Okay, what's my initial value? I should have done that first, but that's okay. 25,000. What's my asymptote? Well, what is asymptote?
Where a region that doesn't cross.
What it approaches but does not touch, right? Well, how am I going to know what the asymptote of this is? We got to graph it, so do it with me. We're going to graph. So 25,000 times 1.032 to the x. All I did was I took the equation on my paper and put it in the calculator. Okay, hit enter. What happens?
Nothing.
You can't see it because it's really big numbers, right? So what do we need to do? Zoom out. So menu. 4 for zoom. 4 again for zoom out. Hit enter. Keep hitting enter. Not super fast, but until you can see the equation or the graph. And there it is. So what does it approach but never touch? 0. So y equals 0. Okay. In real words, okay, that goes along with the problem. What does my A number represent? Well, what is the A number?
Initial population.
A is the initial population, which is 25,000. So how could I write that as a complete sentence? What does A represent? The what?
Population.
The initial, put that keyword in there, initial, population of Johnson City in 1990. Make sure you got that initial word. The beginning, the initial, the start. Okay? You got to have those keywords in there. Now, what does the B represent? The what?
The rate.
The rate of what?
Oh.
The growth rate over what? Or per what? Years. So the growth rate per year. Good. The growth rate per year. Okay, now it doesn't say that's on there, but what if it said, what's the population after 3 years? If it said, what's the population after 3 years, what would you do? Plug in where? What?
The 3 in the
Put the 3 in the X. So let's see. What would the population be after 3 years? How fast would it be growing? So 25,000, 1.032 to the third power for 3 years is what? Did it grow? From 25,000 to 27,000? Yeah, just a little bit. After 3 years, is that realistic?
No. Yeah.
Probably just a little bit of growth after 3 years. Okay. What if it said, what's the growth, or what's the population after 5 years? What would you do? Plug a 5 where? The X, because X represents what? Time. Okay. All right, number 2. Okay, a new car is valued at $24,000 and depreciates 20% every year. Graph the value of the car as a function of time and years, then identify key features of this exponential function. Okay, so is this a growth or decay problem? How do I know? Depreciates, right? Have y'all ever heard car loses its value as soon as you drive it off the lot? Yep. As soon as you buy a car and you leave the lot, it is not worth what you bought it for. Okay, so you guys told me this is decay, so am I going to do 1 plus or 1 minus? 1 minus. Now, 1 minus the what? The percent. So how do I write percent as a decimal? I got to move the decimal how many times? 2 times to the left, so 0.20. And now I'm not doing 1 plus, I'm doing 1 minus because it's decay. So 1 minus 0.20 gives me what? Point what? 0.8. So my new B is going to be 0.8 because we're decaying. What's my initial value? 24,000. That's how much the car is worth. So $24,000. Okay, so initial value represents what letter? A. What's growth and decay represent? B. That's all you need to write your equation. So y equals my initial value, 24,000, times my b, 0.8. And we don't know how much time we're talking right now, so we're going to put a what? X. What's my asymptote? Do I know it right now?
No.
What do I have to do? Graph it. Okay, we got to graph and see where does our graph approach but never touch. So 24,000 times 0.8 to the x power gives me a blank graph. Because it's really big numbers, what do I need to do? Zoom out, menu, zoom, zoom out. Are you with me? Keep hitting enter until you see the graph. What is it approach but never touch? The x-axis, which is y equals 0. Very good. All right, in real words, what does the A represent? Good, the initial value. Of the car. So how much it was worth to start. What does the B represent? In words. You're right, it is the decay. Okay, the decay of the car over time. Does that make sense?
The decay of the
Oh my gosh, the decay of the car's value.
The
That's
car's
better.
value decays.
So what if we said how much the car, if you say decay, that's like I feel like when you say the car is decaying, like it's losing like a door, and then it loses like another door, and then it might lose a wheel. Does that make sense? Like it's decaying, like it's going away. So I would say how much the car depreciates. Why don't we reuse the word it used in the problem? Depreciates over time. Over time each year. Because we're talking years. Okay. Now, what if I said, let's look at this. What if I said, what is the car worth after 3 years? What do I do? Okay, let's look and see. Hold on, you're not going until I tell you to. So, sit down. 24,000 times 0.8. So after 3 years, look how much the car's value lost. It went from 24,000 to 12,000, almost half its value in 3 years.
Why?
What does that tell you? As it loses its value, you start putting miles on it, things start breaking, it's not as nice as it is as a brand new car. Okay, you guys have a good lunch, and then I'll see you after and we'll practice. Bye.
Bye.
Have a good lunch.